So now we're on question 4. Given below is the experimental data of the mean activity coefficient for sodium chloride and its dependence on molality. Calculate the mean activity coefficient at each of the values of B using Debye-Huckel limiting. So this is real experimental data of the mean activity coefficient. They want us to almost, so it's almost like this would be experimental. They want us to calculate, which also means what's the theoretical, right? So we need to calculate, plot this first of all, and they want us, see the other thing too is, right, you're gonna need ionic strength. So let me try and draw this a bit better. You're gonna be given B, so the first one would be 1 times 10 to the minus 3, then it would be 2 times 10 to the minus 3. They're going to expect you to calculate ionic strength. And then you'll need to make so this is calculating the ionic strength. This one would be the square root of it. So how do we calculate ionic strength? So ionic strength is 1/2 add up the charge squared times B over B naught, the molality. So in this case, it's sodium chloride, so you're going to get 1/2 sodium chloride. When you do the sodium ion, it's, for instance, I'll do the first one. The first one is 1. That's the charge. The molality of it is 1 times 10 to the minus 3. Then it's a 1-to-1 ratio with chlorine, so you're going to get a -1 times. So obviously you're going to get ionic strength of that. You would technically have Excel put this ionic strength. For sodium chloride, there'll be the same numbers as this. Then Excel will take the square root of these numbers over here, because this right here will be your x-axis in your graph. Then you're going to have to calculate the calculation of this in theory. I don't know, you could call it theory or calculated. Is -a z times that. Now what's interesting about this is, once you have this and you plot this as y, this is your x, this becomes your slope. But this right here, if I put in the values of a, which if it's log, it's 0.50, this is a +1, this is a -1, I already know the ionic strength. So if I calculate this from this, do you see how this has to be a perfect straight line relationship? So if I graph these calculated results of this log of this versus I to the 1/2, it will be a perfect straight line, right? And it turns out it will be a negative slope. So you're going to get something like this. So you need to calculate this. So you could have Excel calculated, right? for each one of these concentrations and hence the ionic strength, you calculate what gamma is going to be from the limiting law. You'll also have the experimental values that you were given. So in other words, the calculated from the limiting law will give you a perfect straight line right through zero. And it turns out, as I understand it, the data you were given will look more like this. See how it doesn't go through zero and it's got a different slope? So it's asking, how well does the limiting law fit the experimental data? Well, the one thing I can tell you is the experimental data give you a nice straight line relationship, but the slope of it is different, so it doesn't fit this one very perfectly. And that's about all we can say. So I need to see this graph and the chart that showed you calculate. That's pretty much it. And that will do.